let us get started. All right. So this session is a developer session. Why wait for SharePoint 2010 when you can write SharePoint code for 2007 that will migrate easily to the 2010 platform? This session is for developers and architects. If you're not a developer and architect, you are still welcome to stay, but you might start getting lost when we start breaking out the code. Okay. My name is Eugene Rosenfeld. I'm the CTO of Blackblade Associates, two-time SharePoint 2007 MVP, and a blogger. The title of my blog is Things That Should Be Easy.blogspot.com. So it's, that blog is dedicated to all the little things that should have taken an hour that ended up taking 3 days. So again, this session is for developers and architects. You will need to have development experience in order to get the most value out of this session. We are going to be focused on strategies and best practices for writing code that is going to migrate easily from 2007 to 2010. We're not going to have a one-size-fits-all trick that's going to magically solve all of our problems. We're going to look at multiple strategies for getting different types of code to run on multiple platforms. Okay. If we want a one-sentence or two-sentence summary of everything that we're going to discuss in this session, it is this. When you're migrating from SharePoint 2007 or 2010, if there's something that's going to break, chances are it's going to be the user interface. The user interface in SharePoint, and this was true from 2003 to 2007, that accounted for most of the breaking changes when migrating from one version of SharePoint to another. Right. So for those who are looking for a technically correct answer but practically useless answer of how to do less migration of code from one version of SharePoint to another, the answer is deploy less code. Now that might seem kind of like a snippy answer, but we'll actually see in the presentation how we can deploy less code to SharePoint while still having non-trivial applications. Okay. We will look at working with the user interface and making that portable between versions of SharePoint. We will look at writing code that is optimized for the various versions of SharePoint platforms. And we will look at how writing good packaging and deployment for our applications can really, really help us migrate from 2007 to 2010. Oh, and by the way, Microsoft is already ramping up on the next version of SharePoint. So we'll be revisiting this topic in maybe about 2 years or so. Okay. So for the user interface, best thing I can suggest for you for the user interface if you want your code to migrate easily is use as much of the SharePoint out-of-the-box UI as you possibly can. Microsoft is going to do a lot of regression testing and a lot of testing all around in order to make sure that their user interface components migrate from one version of SharePoint to the other. They obviously will not test any of the code that you write for this. Try not to create pages in the SharePoint user interface. Rather, create web parts. Reason for this is web parts that are written using the server object model typically have a very, very good, almost no code change migration from one version of SharePoint to the other. When we migrated from SharePoint 2003 to 2007, most of the web parts that were using server-side code did not even require a recompile. Same with 2007 to 2010. Most web parts that used server-side code did not require any recompile. You could basically take the DLLs from one version of SharePoint to the other, migrate them over, or deploy them on the new version of SharePoint, and they would work just fine. Okay? Pages, not so much. So, said server-side web parts. The tricky part in web parts, especially ones that try to get that quote-unquote Web 2.0 feel, is Ajax, or more generally speaking, JavaScript. JavaScript tends to not migrate very well from one version of SharePoint to the other, and this is because the layout and structure of the page that the JavaScript is working against changes very, very heavily from one version of SharePoint to the other. Right? Of all of the various versions or ways that we can use Ajax in our applications, ASP.NET Ajax tends to migrate more or less well, with the caveat that you have to make sure that the ASP.NET Ajax runtime is deployed on the SharePoint 2007 platform using the .NET 3.5. Right? The .NET 2.0, there's a lot of inconsistencies between the initial implementation of ASP.NET Ajax and the 3.5 implementation, which SharePoint 2010 uses. Who's anybody familiar with the Web Part Page Services model in SharePoint, WPSC? Okay. So this is actually one of the oldest components inside of SharePoint. This has been around since SharePoint 2001. And this is a JavaScript library that is available for your JavaScript code to interact with SharePoint web parts on the client side through JavaScript in a very simple way and in a way that is compatible across multiple versions of SharePoint. So you can do things like iterating through the various web parts that are on the page, and you can read and also set web part properties using JavaScript. So very useful and a very nice way to access these user interface components in a way that is going to be consistent across the various versions of SharePoint. jQuery or other UI library is also an option, but this option, if you're using that to go after the page elements directly, you're going to obviously encounter issues between the various versions of SharePoint because the page structure has changed dramatically. New in SharePoint 2010 is the ECMA script. Now, this stuff is obviously something that you want to take advantage of in SharePoint 2010 if your web part is running in SharePoint 2010, but something that is not going to be available in SharePoint 2007. So ideally, if we're writing a web part, it would be really nice if it could somehow know whether it can take advantage of the ECMA script or if it has to fall back onto something else. And we'll actually look at an example of a web part that does just that later on in this presentation. Okay. So we said that reusing the out-of-the-box components is a great way to ensure that our code migrates easily. Well, a really nice way of making sure that our code migrates easily is not to deploy any code at all. And the way that we can write web parts that do nice things without writing any code is to reuse data view web parts. Anybody work with data view web parts? Fair amount? Good. So what's the biggest pain point of the data view web parts from a developer's perspective? The GUIDs, yeah. You create this nice, well, hopefully nice looking web part in SharePoint Designer, and you're thinking, oh, great, I've saved all this work, but it's got the blasted GUIDs embedded inside the web part, which means that I can't reuse this thing. That's awful. Well, fortunately, there is a workaround for this, for the clever developer. The approach that we take to make these data view web parts reusable is we do the initial design in SharePoint Designer. Then we export the web part. When you export a web part, all you get is this nice XML structure that has all of the properties and settings for the web part, including the connection information in where all the GUIDs are stored. So we take that, we export it, and we templatize it. We take everywhere where that GUID is referenced for the list and replace it with a token. I personally like to use brace % list underscore ID % brace. You can use the token of your choice. Then we take that templatized data view web part, we put it into a Visual Studio solution with a feature, and all the feature does, it doesn't have any components, it just has a feature receiver, and when it gets activated on a particular website, it reads in that templated data view web part, replaces the tokens with the actual list GUIDs for that website, and places the web part onto the page. Really slick, and the best part of all is that when that web part is running in the page, it is not custom code that I wrote, it is Microsoft's data view web part that just happened to have gotten placed there in an automated fashion. So I like to do this through a feature. You can do this through a console application, a Windows Forms application, a custom ASP.NET page, a workflow. Pick the method of your choice. And the best part of all, as I said, when it's running in the page, it is not your custom code, it is Microsoft's code. Okay. So we're going to take a quick look at this in action. Now, for the sake of time, I tend to go over on this particular presentation, and we only have an hour for this. So for the sake of time, rather than doing a lot of demos, instead what we're going to do is more code walkthroughs, because the kinds of demos that you typically see at a conference, the Hello World web part, they don't do anything very exciting for the most part. So in this particular session, we're not really concerned with what the web parts do or what the code does. We're really concerned with how do they do it. So that's the part that we're going to focus on. Okay. Okay. So here is my project. Okay. We can see that this was built using the WSP Builder tool. Here's my feature. And as we can see, all it has in here is feature.xml. There's no manifest file in here. And here is our templatized web part. This is our templatized data view web part. And if we look at this, if you wanted to, you could see that it basically looks just like a regular data view web part looks. And in fact, we can see that the type that this web part is loading is not our own custom code. It is Microsoft.SharePoint.WebPartPages.DataForm web part. Right? So I'm not deploying any custom user interface code into SharePoint. Okay. So the rest of the stuff is not particularly exciting. There's conditional formatting and other stuff in here that I didn't really want to write a custom web part for, that a data view worked very nicely for. And ultimately, in the data source section, this is where my list GUIDs would normally be. So normally, that over there would be a nice GUID. So I took that out, replaced it with my token. Oops. And so everywhere that this GUID would normally appear is replaced by that token. Okay. All right, fantastic. So that's not too bad. That's find and replace. Notepad works great for that. So where does the magic happen? Well, the magic happens in feature.xml. This is my custom feature. Since we're dealing with a web part that we want to place on a web-by-web basis, we want to make this a web-scoped feature rather than a site-scoped feature. And again, it doesn't have an element manifest. It just has an element file. Basically just points to that templatized web part that we created. And all of the work is done inside of this receiver class. So this code is run when the feature is activated. Let's take a look at that. Okay. And so this is standard feature activation code. When the feature is activated, I want to get a reference to the current web in which I am running. I want to get a reference to a task list called tasks. If one does not exist, I will create one. Then I want to read in the contents of that templatized web part. And then I want to replace the tokens with the actual GUID of the task list that I want to use, that I want the data view web part to bind to. Right. So here's that task list ID that I want. And now finally, I have the instance of the data view web part for this web page. I'm going to get a reference to the home page for the site. I'm sorry, for the SP web, and then I'm going to add the web part, the instance of the web part to that home page. So this code is being run inside of feature activation code. Again, you can run it in a Windows form app, console application. You pick. And ultimately, what you get on the page is a nice, well, hopefully it's nice, nice data view web part. Okay. All right. So, well, that was great. But data view web parts, there's only so much you can do with them, even if they are easy to deploy. Sometimes many times we need to be able to actually run server-side code inside of our web parts and do non-trivial things. All right. When we have to do this, we have to consciously make an effort to reuse existing SharePoint web parts, particularly the list view web part. How many have ever needed to create a master detail type view in SharePoint? Yeah. You know, you have a list of stuff on one side, user clicks on one of those items, and then they get a detail, the details for that particular item that they clicked on. So SharePoint has a very nice infrastructure for creating those types of views called web part connections. Right? So for the web part connections, it turns out that we can not only use the web part connections in order for our custom web parts to talk to each other, but if we know the correct interfaces, we can have our web parts talk to SharePoint's web parts. So now we can do things like saying, you know what, I need this master detail view. Well, SharePoint's master view is pretty decent. You know, that list view web part does a lot of stuff. All I really want to do is write that custom detail view. And what I'd really like to do is you know, have that out-of-the-box SharePoint list view web part, allow the user to select an item, and then send that data to my web part, and then my web part will present the details and let the user take further action on that particular item. Web part connections make that process very nice. Again, the trick here is to know which interfaces to implement. So for a list view, the iWebPart field, iWebPart row, and iWebPart table, and for filtering data, the iFilter values. Okay. So let us take a quick look at a web part that actually implements those interfaces. One thing that's really nice to point out is that a web part can act both as the source for a connection, the web part that sends the data to somebody else, and it can also act as the consumer for the connection, the web part that receives the data from another web part. And it can do so at the same time and participate in multiple web part connections with multiple web parts on the page. So you can have, for example, one master web part that sends the detail to a second web part that when the user clicks on an item in that web part sends details to a third web part, to a fourth, to a fifth, as deep as you need to go for your particular application. Okay. Okay. So let's take a look at this connector web part real quick. Quick show of hands while this is loading. How many people have played around with the web part connections in SharePoint before? Oh, fantastic. Anybody play around with them in SharePoint 2003? Yeah, it was good times. Yeah, I think I almost cried the first time I had to write the web part connection code for SharePoint 2003. Is it 13 methods that you had to overwrite? Oh, awful. And so easy now. Yeah. Yep. Yeah, and now it's all encapsulated in one attribute. It's fantastic. You know, I think that Microsoft put in these new loading screens in Visual Studio 2010 and Office 2010 to mask the slowness with which the applications load. I definitely remember the previous versions of the applications loading much faster than these. Now, this web part, the next web part, we will actually see a quick demo of that running both on SharePoint 2007 and 2010. So that'll be nice. Wow. I think computers know when multiple people are looking at them. Shameful. So, quick show of hands. For the applications that you're writing, how many people are writing applications that are mostly encapsulated inside of a web part or inside of user interface? Okay. Is anybody writing service applications yet? Not yet? Okay. Are people writing SharePoint applications that talk to external data sources? Databases, SAP, web services. Okay, excellent. Yeah, you'll like the second part of the presentation. Wow, I apologize for this. This is taking an inordinate amount of time to load. All right, let's let this load and come back to that. So remind me to come back to the connector web part. Okay. So, we've seen two examples of ways that we can reuse the out-of-the-box SharePoint components. Using the web part connections to have some custom code talk to other out-of-the-box SharePoint components. And we've seen how we can use no custom code to automate the deployment of the data views. So let us now talk about platform optimization in SharePoint and basically how to write things that are not necessarily user interface code. Okay. So the goal of platform optimization is to write code that will run on multiple versions of SharePoint and will take advantage of the features that are unique to the various versions that the code is running on. The goal here is not to write a web part or a piece of code that is the lowest common denominator between the various versions of SharePoint that it's running on. We want to be able to take advantage of service applications if we're running on SharePoint 2010, or revert back to operations without service applications if we're running on SharePoint 2007. We want to be able to take advantage of ECMA script if we are running on SharePoint 2010, or revert back to to another mode of operations without using ECMA script if we're on SharePoint 2007 or 2003. Okay. There are a couple of pieces to writing code that is quote-unquote platform optimized. The first step, obviously, is platform detection. You can't optimize the execution of your code unless you know which platform you're running on. So we have a couple of ways to do this. Oh, by the way, the chances are if you actually care about this, you're probably either a product developer, you're in SharePoint hosting, or you're supporting a larger heterogeneous environment. Is anybody here who cares about this stuff not in one of those three categories? Okay. Oh, what category are you in?
I just want to make sure that I'm writing stuff that I can take with.
Fantastic. Excellent attitude. Okay. All right. So let's take a look at some of the detection mechanisms that we have. One of the mechanisms that we have is actually using the object model and using the .NET framework in order to do our platform detection. So when we're doing this, we try to load an assembly that is unique to the highest order platform that we want to detect. So for example, if we want to know, are we running on SharePoint Server 2010 or SharePoint Foundation 2010 or Windows SharePoint Services, first we want to try to load an assembly that is unique to SharePoint Server 2010, such as Microsoft.Office Server.14 as the version number. If our load fails, and this will generally fail with a file not found exception, then we know we are not running on that platform. Then we can try to load the Microsoft.SharePoint DLL to see if we're running on at least SharePoint Foundation. Here's a quick question. Why don't we try to, for example, load Microsoft.SharePoint first? I'm sorry?
Because it might be there.
Yeah, and in fact, if we're running on SharePoint Server 2010, we will have Microsoft.SharePoint version 14 running on there because SharePoint Foundation is a prerequisite for SharePoint 2010. So if we're interested in knowing whether we're running on the server platform rather than the Foundation platform, loading the Microsoft.SharePoint DLL doesn't really tell us anything. Well, let me rephrase that. It doesn't tell us specifically what we want to know. It tells us that we're running on at least SharePoint Foundation. Well, we're actually going to see that. There's a couple of ways to do that. One way to do this is to use system.reflection. All right, so system.reflection.assembly.load, and then the fully qualified assembly name. Another way that you can actually do this is if you're reasonably confident that some version of Microsoft.SharePoint will load, you can check the version information. You can check the full assembly name, .version, .major version, and see which version of the assembly actually got loaded into memory. The only downside to that approach is that if you are not running on any SharePoint platform, then your code will not load at all, and you'll have an exception. So if you want to write, say, for example, a console application or Windows Forms application or a Windows service, something that is running outside of the SharePoint, so something that's running outside of the SharePoint web user interface, but something that needs to talk to the SharePoint object model on the server, you really want to have some startup routines that check to see if SharePoint is even installed on the server in which you're running. Okay. We can also check the registry. And again, it's the same type of approach as with the object model, except that instead of doing the assembly load, we want to check for a registry key that is unique to the platform that we're trying to look for. Okay. This is one of my personal favorites, using the HTTP method. Let's say somebody gives you a URL. Let's say you have an application that uploads a file to a remote SharePoint server. I don't know, let's call this maybe Microsoft Word. And somebody clicks save, I want to upload this to SharePoint. They give you a URL. How do you know if SharePoint is even installed at that endpoint, if it's even available? And if it's installed, how do you know which version of SharePoint is installed there? Right. So the approach that we take is we actually look for one of the web service endpoints that we know of. So for example, if we try to get the lists.asmx web service and we don't get a file not found, or if we don't get a 404, then we know that at least Windows SharePoint Services v2 is available at that remote endpoint. If we go for office file.asmx, we know that at least Microsoft Office SharePoint Server 2007 is available at that endpoint. Right. And so this approach, we use the same methodology that we have with the other approaches. We try to pick a web service URL that is unique, that was made available in the version of the platform that we're trying to check for. So obviously, if we're looking for Windows SharePoint Services v4, checking to see if list.asmx is there doesn't really give us enough information, because that will be there for Windows SharePoint Services v2, v3, and v4. It doesn't tell us enough about the version of the platform that's out there. Okay. File system, everyone's familiar with the 12 Hive, 14 Hive. By the way, so 6.0, that was SharePoint v2, 12 is SharePoint v3, 14 is SharePoint v4. What's in the 5.0 and 4.0 directories? Anybody heard of front page server extensions? Yeah. 4.0 and 5.0 is front page server extensions, 4.0 and 5.0. SharePoint v2, the reason that it's in the 6.0 directory is because it's really the next version of front page server extensions. Okay. Some trade-offs for deciding which platform detection mechanism you want to use. The object model is nice if you're actually running on the SharePoint server, but it can be a little bit complex. The registry method can be easier. However, you need to have potentially a higher level of permissions in order to use the registry method. Especially if you're executing in UI code, unless you elevate permissions, you may not actually have permissions to read particular keys out of the registry. And of course, my favorite for using the HTTP method is because that's the only mechanism you can really use to check something on a remote endpoint. Okay. All right, so let's take a look at some examples of object model and HTTP code that is designed to run on multiple versions of SharePoint. Okay. So in the object model, anybody work with languages that support late binding? Maybe Visual Basic 6 or earlier? Yeah. Okay. So when we're dealing with object model code and doing things dynamically, we start to get into decisions whereby we can decide whether we're going to use the classic model for executing code, where we go Microsoft.SharePoint.splist and we get all the IntelliSense and whatnot in Visual Studio, or we have the ability to use late bound code, which is the much less safe way you can think of mechanism for executing code, but that is potentially more flexible. So we'll see a quick example of that. All right. So here's some early binding code that we have. So inside of this try, we have the assembly that we're trying to load, and we're trying to load the SharePoint v3, the Windows SharePoint Services v3 assembly. So if we don't get an exception during this load, that means, so if this assembly reference is not equal to null, then we can go ahead and use Windows SharePoint Services. And when we're using Windows SharePoint services, we now are able to get the full IntelliSense. So we can do a new Microsoft.SharePoint.SPSite object, for example. So one thing to point out, the reason that we are referencing, the reason that we're doing all of this stuff inside of another method is because any block of code that tries to access a type that is inside of an assembly that is not currently loaded is going to fail outright. And there's really not much you can do as far as error handling goes around that. The only thing you can do in your application is make sure that the execution of the code does not get to that block of code where those types are declared. So that's why, if you'll notice, the type, anything in the Microsoft.SharePoint, is all declared inside of this function. It's not declared globally inside of the class. That makes this code able to survive even if SharePoint is not installed when this code executes. Okay. So late binding code. Again, we're doing the same thing. We're trying to check to see if the SharePoint assembly is loaded. So are we running on at least SharePoint v3? And if we're doing that, notice here, we're not actually ever declaring any object of type Microsoft.SharePoint.something. All of our object declarations are of type object. And the way that we're accessing the properties and methods of these objects is by using the invoke member. So this is all doing late binding stuff. If we misspell a method or a property name, or send the wrong parameters to a constructor or method call, we will not get any compile time checking. We will only get runtime errors when we do this. And we'll only get particularly nasty runtime errors. The great method.invoke errors that everyone loves. Really fun to debug. However, this way of working with situations where the object may not exist, or you're trying to work with multiple versions of the same type, it's a lot more flexible than the early binding example. All right. So let's take a quick look at the HTTP code for working with various versions of SharePoint. Okay. So in here, we actually have. Whoops, sorry about that. In here, we actually have inside of our application when we created this, we went out and we created the proxy class for the SharePoint web service endpoint that we're interested in. So that gives us all of our types even though they're all of our proxy types to that particular web service. In this case, we're using the site data web service. Okay. So the first thing that we do is we're actually going in and trying to invoke this. And if the invocation fails, then down here we know that, hey, this is not the version of SharePoint that we were looking for. So the only trick to this is, if we want to work with multiple versions of a particular web service, the actual WSDL for the web service can potentially change, and has changed from the various versions of SharePoint from 2003 to 2007 and 2007 to 2010. So in order for us to work with the web services in this manner, where we have the nice proxy classes, we actually have to go out and generate the proxy classes for the different versions of the web services that we want to work with. So I think the lists web service is a good example, right? It's got in one of the versions, it actually had the check-in and check-out methods on there for a list item, right? So in order for those to be available, we actually need a proxy class that is generated against the version of that web service that had those methods on there, and potentially another proxy class against a version of the web service that did not have those methods there, to make sure that when the SOAP messages are serialized and deserialized over the wire, that they're done so in the proper format for that version of the web service. So what that means to us is that when we're developing this application, we actually need a SharePoint v2, SharePoint v3, and SharePoint v4 endpoint in order for us to be able to generate the proxy classes from those various systems. Or we need to have saved the WSDL files from the web methods that are available on those different versions of SharePoint to some directory on the file system so that we can generate those proxy classes off of those. Okay. All right. So let me see. Hopefully this application is loaded already. All right. So before I go to the multi-platform web part, I want to jump back real quick to the connection web part. So if you notice, this particular web part, this is a visual web part that I created in Visual Studio 2010. But the code that we're going to look at is identical in SharePoint 2000, or for a SharePoint 2007 web part. Obviously, this particular web part instance is not going to run cross-platform because it is created with the SharePoint 2010 toolset. In the next example, I actually have a web part that is created in Visual Studio 2010 but can still run on SharePoint 2007. So I'll show you what that looks like. Okay. So the web part stuff itself is basically the same. You're still inheriting from system.ui.webcontrols.webparts.webpart. We still have all of the typical types of method overrides that we have in web parts, on pre-render, create child controls, onload, data bind, what have you. The trick is, in order to get this web part to work, to be able to communicate with the out-of-the-box SharePoint web parts, here's where the magic happens. We create methods that are decorated with either a connection consumer attribute or a connection producer attribute. The connection consumer attributes signify to SharePoint that this web part receives data from another web part. The producer attribute signifies that this method sends the data to another web part. And as I said, the methods that we're looking at here is here's a method using iWebPart parameters. Here's one using iWebPart field. So by using these particular interfaces, this is what allows your code to talk to the out-of-the-box SharePoint web parts. And this code, if it's done the right way, it will run seamlessly. It doesn't even have to be recompiled from SharePoint 2007 to 2010 and still be able to talk to the various web parts in SharePoint. So these are the consumers. This is what lets us get data from SharePoint. Here are the producers, or the providers. These let us send data to the SharePoint web parts. Okay. As you can see, there's not a lot of code in there. All you have to do is either grab the data that these connection points are sending you and store it inside of your class and do something with it, or you have to send the data to the SharePoint web parts. It's really not very complex. The hard part is knowing which interfaces you have to work with. Okay. So let me open up the next web part. This is the multi-platform web part that we have. So as you can see, this is one that I actually converted from Visual Studio 2007 into 2010, just so that we can see what we can do to make a web part in Visual Studio 2010 that still runs on 2007. Unfortunately, what this means is that we can't use the Visual Studio 2010 SharePoint tools. We pretty much have to use the same tools that we would have used in Visual Studio 2007. So in our case, this is using the WSP Builder extensions for Visual Studio 2010. So this is just some test code, but the web part itself looks exactly the same as it would have in Visual Studio 2008. So here's the web part getting uploaded, the web part file getting uploaded that tells SharePoint the web part is there. And here's the actual web part. Now, what this web part does is it does something interesting. It basically writes out a couple of buttons. And if it detects that it's running on SharePoint 2007, when you click the button, it will do a server-side postback and show you that, hey, you clicked this button at this particular time. However, if the web part is running on SharePoint 2010, it will integrate with the ECMA script and send a little notification, right where you'd normally see that little loading notification, and give you that notification before it potentially does a server-side postback. So to see how this is done, let's go to our utilities class. So this utilities class does all of its checking upon the initialization of the type, which means that it does its work only when the W3WP process loads. You don't have to perform this check every time the instance is initialized. The version of SharePoint that's running is not going to change while the W3WP process is running. So save yourselves a lot of time in execution and just do that when the type is instantiated. Okay? So it tries to load the WSSv3 assembly. And here's our familiar code. Right, in which it does the reflection.assembly.load, Microsoft.SharePoint, and loading specifically the 12.0 version. And then to see if we're running on SharePoint v4, we're loading the 14 version. We also do something interesting. When we're running on SharePoint 14, we actually also try to see if we're running on SharePoint Foundation or SharePoint Server. And if we're running on SharePoint Server, then we know that we can talk to a particular web service application. So this one I think we'll actually take a quick look at. Good. I have 10 minutes. Okay. Okay. To do a quick resize of the VMs. Maybe not so quick. There we go. All right. So we've got a SharePoint 2007 instance running here. And here we have an instance of our multi-platform web part. So it has detected that it's running on SharePoint 2007. So when I click this button, it is going to do a server-side postback in the classic way, and then update the time when they got clicked. Okay, nothing too fascinating there. However, we've got the same web part running here. Pay no attention to the error code. The stuff that's of interest is working. So we're just going to refresh this page real quick. So on the 2000, when it's detected that it's running on SharePoint 2010, it actually rendered out two different buttons down here on its user interface, and it is telling the user that it's going to be using the client-side object model that SharePoint 2010 has. So as soon as this refreshes, we'll click that and we'll see the great fun little notifications. Okay. Okay. Let's see if it's ready or if I have to wait a second. All right. Let's let this thing refresh. I want to move on to the next portion of the presentation because we actually have a nice case study in here about working with non-trivial applications. Okay. All right. So we looked at working with web service code, with working with object model code that will move over, and with user interface code that will allow us to move our applications over from 2007 to 2010, and will also allow our applications to run on both platforms simultaneously. However, there are cases where there's just nothing we can do, and we have to have artifacts that are unique to the SharePoint platform. For example, things that we're loading into the 12 Hive or the 14 Hive. Some of those items, like for example, a custom action feature, the schema for that has changed between SharePoint 2007 and SharePoint 2010. If you try to take a custom action schema file or a custom action elements XML file that it has all of that ribbon stuff in SharePoint 2010 and put on 2007, SharePoint's not going to like it. And likewise, if you take a custom action file that's written for SharePoint 2007, it'll deploy to SharePoint 2010, but in many cases it just won't show you anything. Right? So the only answer that we have for that is at some point we're going to have to create two different versions of that custom action file, one for SharePoint 2007, one for SharePoint 2010, and we're going to have to make sure that if our code gets deployed to 2007, the 2007 version gets deployed, and if we're running on 2010, the 2010 version of that custom action file gets deployed. When we have to do things like that, having a good packaging and deployment model is essential. Because what we don't want to do is we don't want to have to branch our entire code base just because we have to create variations of one or two artifacts. Right? If I'm writing a custom action that invokes a bunch of code behind the scenes, and I want this thing to appear in the ribbon on SharePoint 2010 and appear in the actions menu on 2007, chances are most of the code is going to work exactly the same on both platforms. So I don't want to have a variation of that code. I just want to have a variation of that one XML file. So having a good solution layout for that makes things really nice. And we'll actually look at how we solve that problem with one of our own applications. All right. So when we're doing this, the trick to making all of this stuff work is to separate out as much of the parts that are going to give us trouble. And again, we said that's going to be mostly the user interface from the rest of the stuff. Well, that sounds like NTR architecture to me. Right? You've got all user interface pieces in one project / one assembly. You've got your data access somewhere else, your processing logic somewhere else, and finally you have a setup project. Or maybe you have multiple setup projects that will go and merge all of this code together and make sure that it deploys properly on SharePoint 2007 and 2010. When you're creating non-trivial applications, the days of having the setup combined with your code are really not going to fly. Because you're going to have to create variations in your setup that account for the differences in the different platforms. So what that means for us is this type of model where all of the code and the deployment is all inside of this one project. That's not going to work in a non-trivial application. Okay. So, can we get even better than N-tier? The problem with N-tier, especially in the SharePoint world, is even if you have multiple logical tiers, they're still all being deployed into the SharePoint farm. And everything that you deploy into the SharePoint farm is something that you have to do regression testing on and something that you potentially have to migrate code-wise when you're going from 2007 to 2010 or when you're going from 2010 to whatever the next version is. That's a problem. A services-oriented architecture will give you the ability to have multiple physical tiers in your application. The idea here is you deploy only the components of your code that actually require SharePoint to the SharePoint farm, and everything else stays off of your SharePoint farm. Because everything that's not on your SharePoint farm, when you go from 2007 to 2010, does not have to go through regression testing. It does not have to get migrated. So, how do you decide what goes where? Well, the main question that you ask yourself on the left-hand side is, does this particular piece of code or logic require SharePoint? If it does not require SharePoint, then it's inside this bottom row down here. And the way that we can get this to communicate with SharePoint is it can be a SOAP web service. It's a piece of code that can have a SOAP interface or REST interface or some type of remotable interface. And this code runs on some place that is not SharePoint. Maybe it's a separate server. Maybe it's a hardware appliance. Maybe it's out in the cloud somewhere, not on the SharePoint farm. Oops. If the code does require SharePoint, well, that's usually the user interface code. So that's going to be in SharePoint. That gets deployed, so that's probably your web part. Maybe it's an asynchronous event receiver or a SharePoint workflow, potentially. And this part of the code that is deployed to SharePoint will communicate with the portions of the code that are not running on SharePoint through some sort of remotable interface, whether it's SOAP-based or REST-based, or Corba, or DCOM, whatever you want to use. Okay. So let's see if, before I go into this, let me check real quick to see if this VM has refreshed itself. There we go. Okay, so here's the multi-platform web part running on SharePoint 2007. It's got the two buttons down here. If I click the client-side click, we have the notifications on the right-hand side showing up. Right? And we notice that it's not posting the page back. And then we can click on this other button, and this will do a notification and then do a regular post back. So it's the same web part, exact same code base. It just recognizes which version of the platform it's running on and uses the features available on that platform. It's not a lowest common denominator web part. Okay. So, I'd like to talk briefly about an application that we had internally that we had to migrate not only from SharePoint 2007 to 2010, but 2003 to 2007 first, and then 2007 to 2010. And let's see how that went. Okay. This was a document processing application, and in the first iteration, the layout of the application probably looked fairly familiar. It had an N-tier architecture. It worked. It did what it was supposed to do, and everything got deployed onto the SharePoint farm, onto the SharePoint web servers. Right? Very familiar type of application architecture. So when we took that application and moved it from 2003 to 2007, we had to do regression testing on 100% of this code base. That was painful. This is, like I said, this is not a trivial application. This is, tens of thousands of lines of code. I was not liking it at that time. So, during the 2007 life cycle, we really wanted not to repeat that process. So what we did was we took the application and we re-architected it. And we re-architected the application using a services-oriented architecture. We examined all of the code and the logic of the application, and we used this little chart over here to see which parts of the code needed SharePoint and which parts of the code really had nothing to do with SharePoint. And what we found is that we could easily move 85% of the code off of the SharePoint farm. 15, 20% of the code, we had to leave that there. There was user interface and stuff that had to stay. Bless you. Okay. So, what did this give us? Well, what this gave us is that in the original version of the application when we migrated it, we had to migrate 100% of the code. In the re-architected version of the application, we only had to migrate 15% of the code. We saved 85% of our labor effort when going from SharePoint 2007 to 2010 as compared with going from 2003 to 2007. That was nice. The other part that was actually kind of nice is it changed our staffing requirements for this application. Because 85% of this app did not rely on SharePoint, that means that 85% of the development team didn't need to be SharePoint resources. We could actually hire good developers who may not know SharePoint, and they could still help us write this application. And now only 15% of the people on the team actually had to know SharePoint in order to be able to work on this application. And of course, because 85% of this application did not need SharePoint, that means that we had a much easier time supporting non-SharePoint platforms with this application. So, quick summary of everything. When you go from one version of SharePoint to the other, the user interface is what's going to get you, each and every time. Most of the other code migrates fairly easily. The best way to have a trouble-free migration from SharePoint 2007 to 2010 is to write code that is naturally multi-platform aware and that will naturally work on the multiple platforms. Right? For the code that can't do this, such as custom actions, good deployment and good packaging and good solution layout of your Visual Studio solution is the key to making sure that we can take those artifacts and deploy them in a way such that the right version of the artifact gets deployed to the right version of the platform. And of course, if you want to have to migrate less code, deploy less code to SharePoint. We did. Okay? Of course, the reason that we do all this stuff, why we do best practices, because we got a measurable return on our investment, 85% reduction in labor when doing the migration. Right? That's why we do this stuff. You know, we don't do this because it has academic value. We do this because we need to save money. Questions? Okay. There's a couple of sessions that are related to this. Unfortunately, most of these sessions have already occurred. However, because you're going to get the post-conference DVDs and the slide decks, I highly encourage you to look at these sessions from the other speakers. Todd Bleeker's service application session is very nice. Service applications make writing applications that are based on a services-oriented architecture much easier in SharePoint 2010. And please make sure to fill out your evaluations. Thank you.